Hi everybody. So this video is definitely a little bit out of sorts. I'm putting the cart before the horse a little bit here, and I'm shooting this clip here at the end of the video, and I'm going to put it at the beginning of the video. And the reason is I'm going to ask some of you for your help. So what I was going to do with this project was I was going to break it down into little videos, and each one I was going to, as I go through restoring this receiver, I was going to go through some of the most commonly asked questions that I get in emails, such as how do you power up a receiver after it's been sitting on a shelf for a lot of years? What are some of the decisions you make on that? How do you recap an amplifier board? How do you set the bias on a circuit? Little things like that I'm going to break down into little sections. And originally I thought this was going to be a pretty straightforward video series and we were going to go through it. But I got a little bit of a surprise, and actually I kind of like the surprise, but also I'm a little bit perplexed. So what we have behind us, and in the next clip you're going to see what would have been the beginning of this video, where everything's all still assembled and I hadn't had it apart yet. But now that I have this thing apart, and I'm still on my morning cup of coffee, so my voice is a little hoarse this morning. But what we have behind us is a Kenwood model TK80U. And what I'm going to do is I'm going to take the camera off the stand here in a second and take you through some of the things. But essentially, I was able to download the service manual for this. And what I found was a little bit of a surprise. Number one, even though the model numbers are the same, this is a very different receiver from the one in the service manual. On the front faceplate, they're identical looking. Inside, they're very different. This one, and we'll get a little bit closer on it. As you can see down here, I don't know, let me move the camera down a little bit. As you can see down in the bottom, we have vacuum tubes in here. And don't worry, I'll show you up close here in a minute. And in the one in the book, very clearly, it does not have any vacuum tubes. And I'll show you some pictures I'll put up on the screen here of what it should look like. And even in the service manual itself, I'll show you that, you can see there are no vacuum tubes in this one. Actually, it's all solid state. So, a little bit of a mystery. To make matters even more complicated, and I'm off shot again, to make things even more confusing, Kenwood actually repurposed this model number. So there's 3 different devices made by Kenwood with the name TK80. So there is a TK80 receiver, this original one, and it is a TK80U. If you look on the front faceplate, TK80U, and I believe the U stands for US version. And there's this one with the vacuum tubes. There's the one that is on the Hi-Fi Engine website, the service manual, that has a solid state receiver on the front end, or tuner section, RF section. And then they made a shortwave communications receiver, and you guessed it, they named it the TK80. So if you try to search this online, you'll hit a lot of dead ends. There are many different examples of the solid state version, and there are some pictures on Audio Karma and a couple other places showing the one with the vacuum tubes like this. No service manual that I can find. Now, I didn't do a totally exhaustive search, but most of the places, even some of the pay places I looked at, did not have the correct service manual or couldn't prove that their service manual was any different than the one on Hi-Fi Engine. So it's a bit of a mystery, and to make matters worse, I'll show you here in a second some of the differences that go beyond just the vacuum tube front end of the tuner. So let's do that now. And we're going to go handheld on the camera, so if you get a little bit dizzy, get some motion sickness, I'll apologize in advance. So first things first, if we look at the receiver top side, you can kind of compare the two layouts. The capacitors, so if we look here where the capacitors are, it's nowhere near like this. If you look at the actual tuner section, so you can see the weighted flywheel up here on the top, and you can see on the picture, not even close. There's actually a circuit board in here, which is probably your phono section. I'm not sure, but I think this is the phono section, and it's definitely not in the same location there. You can see down here in the front end, the tuning gang, and there's 3 vacuum tubes. There's that new Vista I will show you later, and then these 2 9-pin tubes. They don't exist on this. That's a solid state front end. If we look at this circuit board here, the amplifier board looks relatively simple, or similar, I'm sorry. And however, when we rotate back here, we go to the other, you can see once again there are differences in how this is laid out. So it is going to be a little bit of a challenge, I think, to figure all this out. And again, you're going to see later in the video just how much this amplifier has been worked on by somebody. And I think it was somebody who either did not have a lot of experience or really knew what they were doing, but they were experimenting first and just tacking parts in to see if they could get it to work, and then they gave up on it or something. I'm not sure. Again, I'm not going to judge somebody that I don't know. But this will need to be all removed and properly restored because there's just so much wrong with it. So this video is going to be a little more extensive, or this series I should say is going to be more extensive than I really planned it to be. But I thought it would be something interesting anyway. It just kind of makes me want to work on this even more. The problem is, without having the proper service material for it, it's going to be a lot more challenging because you don't really know what the components are supposed to be, nor do you have a proper alignment procedure for the receiver, which that's the part that I'm the most interested in, is the front end, the vacuum tube front end and all the analog, coils and everything. This would be a really interesting FM tuner to work on. So anyway, let's get to the beginning of the video now and we'll start where I started originally. Hi everybody, welcome back. Well, I haven't been on the bench very much this last week. Things have been really busy at work. So finally I'm getting to doing a few things. And what I decided to do here is a receiver that I took in trade, oh my goodness, a while back. And it's a Kenwood. It's an older Kenwood. I think it's from 1964, 65, somewhere around there. And it's a model TK80U. And I think the U stands for United States or US model, because I believe there's also a TK80. And I'm not sure what the difference is. But this is the one that I took in here. It's a U model. And what I think I'm going to do is, since I don't have a lot of straight time, like long dedicated time to put on the bench here because of how busy things have been, I'm just going to do this receiver in some small parts and try to demonstrate a few things that I get repeat questions for. I get a lot of emails asking different questions about repairing and testing and so forth. So what I'll do is I'm going to break this restoration up into different parts. And each part is going to involve a certain question that I get a lot of. And hopefully it will be helpful to some of you who are just getting into doing restorations and so forth. Now, on that same note, I get a lot of emails every week, and I know I've said this multiple times, but since all the different changes we've been dealing with in the last month or so, as you can imagine, I've been getting a lot more emails. And I've been trying to answer them every weekend, but they are getting a little bit overwhelming sometimes. So do not take it personally. If I do not answer your email quickly, it may be a while before I can get to your email. Maybe just depending on when you email me and when I have time to sit down and answer some of them, you may get a quick response or you may get a delayed response. Just understand it's just because of how much time I have and how many emails I'm getting. I'm going to try to answer the emails in the order that they come in. So I think that'll be the fairest way to handle it. So with all that said, first of all, my camera seems to have healed itself. It's not zooming in little by little on its own, at least that I can see right now. We'll see if this thing holds out through this video. So what I'm going to do on this first episode of this series is I get a lot of questions of how to power up an amp that's been sitting idle for a very long time. A lot of you out there will invariably have a piece of audio gear that maybe you purchased a long time ago or that you inherited from somebody else. You know, maybe your parents had it or an uncle or somebody, and it hasn't been powered up in a long time. And I get the question over and over again. They'll either pose the question, is it safe to power it up? Or I'll get a question, how do you power it up safely after all these years? And how do I know that I'm not going to damage something? So I'm going to try to answer that question and go through a couple of different things that I do personally when I'm faced with that situation. So if that sounds interesting to you, that's what this particular video is going to be about. So the first thing that at least I take into consideration before I power up a piece of vintage audio gear is its actual age. If something was built, 20 years ago, 25 years ago, chances are more than likely you're not going to have to worry about the age of a component, like an old component that if you plug it in now, it'll short out or cause damage. Now, there's always exceptions to every rule. Understand that. Anything can fail at any time. But, from experience, usually things that are, at the time that this video is being made, things that were made in the mid-1990s or even early 1990s probably don't pose a huge risk if you just plug them in and try them out, or at least using a couple of the techniques that I'm going to show you for powering something up safely. Now, when you start getting into things that are 1970s vintage, 1960s, and I'm talking solid state right now, you now have to start considering things like the electrolytic capacitors. Some of them will open or just degrade in performance, so it may affect the sound quality or something like that. But some of them also are capable of developing a high ESR, which is equivalent series resistance. And what that means is that the capacitor no longer acts just like a capacitor, but it also acts partially like a resistor. And what do I mean by that? What I mean by that is it starts to convert some of the electrical energy that's applied across it into heat energy. And that heat energy can be kind of like a self-feeding monster, because that capacitor, as it heats up, the ESR will get even worse, and the capacitor can eventually short out and give you a lot of problems. If it shorts out, anything connected to it is going to be shorted as well. So if it's in the power supply, you can short out your transformer, you can short out your bridge rectifiers, things like that, so you can cause a lot of damage. I know that some of you will say, well, sometimes they heat up and that causes the capacitor to reform, or the electrochemical reaction in the capacitor will kind of cause it to go back to its normal value. Well, that is possible, but in a lot of cases I've seen them short out. So that's something you have to think about on that age of equipment. Now, when we're talking about vacuum tube equipment, back in the 1940s and 50s and 60s, I never ever consider turning those on unless I thoroughly test any of the components that are going to have high voltage across them. Because remember, vacuum tubes run with high voltages. So anything vacuum tube, as a general rule, I will not power them up unless I really inspect them visually and even with some test equipment prior to applying power to them. Especially if it's a valuable piece of equipment that's collectible. You don't want to damage it any worse than it already is. So this one we have in front of us is kind of a middle of the road. It's a mid-1960s. It's solid state, so it does not use high voltages like vacuum tube gear does, but it definitely sits in that realm that we can have problems with capacitors that have developed high ESR or even a short or something like that. The other thing is we don't know where this one came from. So it's one thing if you inherit a piece of gear from a relative and you kind of know the history of it. That's one situation, but the other situation is you don't know where this thing came from. You don't know if it's been damaged or it's had a power surge through it or something. You don't know. So there's a few inspections you want to do. So we're going to start with the visual inspection first. So the first two things I always check on the visual inspection is the condition of the power cord. If the power cord is broken, like you look at this one, it's been wrapped up like this for a very long time, and you can see it's very crusty. This almost, if I bend it, it's going to snap. You can't stretch the cord out. You can see it doesn't want to stretch out. It's very stiff. And if the cord has cracks in it, you don't want to plug it in because obviously you're going to short your mains out right through the cord. So this would be a situation where I may try to plug it in because there's no broken insulation on it yet. But this is definitely a cord that will eventually get replaced because it's not safe. It's dried out and it's going to get brittle. The other thing I check is the fuse. You always want to check your fuse. And let me move the camera down. So we look at the fuse and we can see on this one it says 2 amps, right? So we know that it's supposed to have a 2 amp fuse. I will remove the fuse. And you want to check it, and when we look up close, it does not appear to be blown. You can still see the filament in there, and if we look at the value, let's see if we can find it, you can see it says 2 amps. So it has the correct fuse, and the fuse is good. That is always a good sign because it means that the last time this thing was powered up, at least we know that it drew less than 2 amps, or at least we can assume that. So that's one indication that probably nothing was wrong with this amplifier the last time it was used. The other thing I look at is just to make sure that there's no physical damage that you can see that may be an indication of something being shorted or something. So that all looks good. Now at this point, if this were a receiver that I purchased many years ago and just put into storage, or that I inherited from my parents or a relative or somebody that I know, at this point I would go through and power it up. And I would power it up in a safe manner, but I would not be afraid to power it up. Because this is a receiver that I got in on trade from somebody that I was doing some work for a long time ago, and that we don't know the history of it, We don't know if it's had any water damage or anything, although it doesn't appear to have been in a damp environment because this is a metal case and it's not really very corroded or anything. It looks pretty normal for its age. It's probably safe to plug in, but we're going to assume that this is one that we don't know. So we'll do one extra step before we do the plug-in. Any of you who, like I said, have had your receiver since you bought it new and had it in storage or acquired it, you can skip this next step. But what we're going to do right now is we're going to do a visual inspection. And in order to do that, we're just going to take the screws off the side and we're just remove the top cover. I'll do that real quick off camera and I'll be right back. Okay, this is an ultimate reason, really good example of why I don't power up things that I don't know. There's two things. Number one, the first thing I did was I actually downloaded the service manual for the TK80U. Now, if you look, when this was listed on Hi-Fi Engine, it was listed as a TK80U. But when I printed it out, it says TK80AU. Now, if you notice, at the front end of this stereo, so here's your RF section, your IF section, your multiplex for stereo, all that good stuff. And if you notice, nowhere in there do you see any vacuum tubes. But if we look in ours, what do we have here? We have actually 3 vacuum tubes. We have this one here, and this is actually a vacuum tube. This is fascinating. This is a little miniature tube, and it's known as a nuvistor. Now, when I took this thing in, I had no clue that this one was this version. This is very fascinating to me. I've always wanted to do one of these receivers. I didn't think this was that type, but it actually is. So, first of all, we know that this is not what I expected it to be. But a little more scary, a lot more scary, is when I move over here to the amplifier section. And I'm going to move the camera arm over so you can really see it. Do you see anything that concerns you? So let me grab a pointer here. Here, look all over here. Look at all of these components. Here, over here, look at all these. If I zoom in, you can really see just how many things have been replaced on here. And they really were hacked in. If you look, they just cut on top. They cut the leads off and just tack soldered these new components right onto it. So this amplifier is absolutely not what I would consider safe to power up. The other thing that I'm seeing is around these capacitors down here, I see maybe what could be some leakage from these electrolytics. So they could have problems. So this is one of those receivers where we're probably not going to just power it up, simply because of what we're seeing here. Obviously, this has had a lot of work done on it. And we don't know underneath. Usually when you see a massive amount of components replaced like this, and you can even see here this resistor sticking up off the board, and you can see the one leg is almost touching the heatsink. And on these TO5 type transistors, the case is actually the collector. So anything that's touching this case is actually touching the collector of that transistor. So all these things raise a big time red flag. You can even see here where there's a capacitor, but the component that they're showing on the board is one of those little thermistors or a stubistor. And you can see, I don't know if that's supposed to be like that. So we're really going to have to do some more looking at this before we even attempt to power it up. First, we need to get the correct schematic. Second of all, we need to flip this over and look if any of the traces have been burned on the bottom of the board or damaged. I really want to restore this now because of the vacuum tube front end on the tuner. And I really like the discrete tuning section. When we get to the later episodes of this video, I really like the way this is laid out. And we'll tune all these coils. We'll go through all that. This will be a really fun restoration to do. So taking the cover off the bottom, it probably looks even worse than topside. And the reason I say that is, here's the amplifier board right here. And if you zoom in, you can see just the amount of work that's been done on this thing. And you can see that this is just twisted around here. It's not even soldered. This resistor is literally, they just took it and just shoved it on there and put a big blob of solder on either side to hold it. You can see where the tracks have been broken. And these tracks do not look burned. So what it tells me is whoever was trying to repair this or replace the damaged component didn't have the proper equipment or technique to remove the old components, and they broke these tracks off. See, these old-fashioned boards, a lot of these were hand taped, meaning that this copper clad on here is not very well affixed to the board substrate. And if you put just the tiniest too much amount of heat on these tracks, they'll lift right off the board. They'll come unbonded from the board. So you have to be extremely careful on these when you remove components, or you'll damage the board. And that's what happened down here. So they had to kind of bodge these wires in here to fix it. The other thing is, it looks like they didn't want to have to mark all of these wires and remove them. But really the correct way to fix a board like this that has that extensive amount of damage would be to remove the whole board and get it down on the bench where you can work on it. Which, you know, in trying to just kind of bodge these transistors in here, not good. The other thing I noticed is, here's the tuner section. The vacuum tube sockets are underneath this cover. And if you look closely down here, you can kind of see how that ceramic capacitor is kind of pinched between the main chassis and this module itself. Now, I don't see any evidence that these were ever unsoldered around here and that this module has been removed. So I'm thinking that was factory. The capacitor doesn't look like it's damaged, but it's just kind of squished in there. It's kind of a strange way to be put together. The rest of the tuner doesn't look like it's ever been serviced or anybody has messed with it. Now, maybe it's had the golden tweaker on all of the coils. We don't know that. But it looks like the main work that was done on this amp was on the board here. So this is a really good example of why I never just power something up when it comes in. I did not know where this came from. I didn't know its history. And there you go. So because I wanted to go over this with you all, we are going to power this receiver up. I'm not really concerned if something, we're going to take some precautions to minimize any damage if something goes wrong. But we are going to power this up. So the method that I prefer for this particular situation is called using a dim bulb tester, which is essentially just a current limiting device that you're using. And it's a very simple thing that you can build yourself. If you go to a hardware store, and I'll zoom in for you if I can get around all this mess here. If you look, I have mounted on my bench here this little plastic socket. It's a light bulb socket. And you can put different values of bulbs in here. Right now I have a 40-watt light bulb, but you can put bigger ones. One that I like to use on larger devices is this. This is out of a traffic light, and this one's a 118 or 116 watt. And these are very, very durable. So if something shorts or something, you know, these hold up very well, because they're designed to be in traffic lights outside in all the elements, in the heat and the cold and so forth. And they can still be purchased. Most electrical supply houses will have traffic light bulbs replacements. This one is a light bulb out of a refrigerator or out of an oven. And again, those are lower wattage usually. They're 40 watts. And the 40-watt bulb will limit that current big time to your device. So if you're just going to power up an old radio or a receiver that you know might have a short in it or something, chances are that 40 watts is not going to cause any damage. Anything can happen, okay? So some of you will say that, but in most instances when you use a 40-watt bulb, you are really going to limit the current to this receiver. Now if you try to power up one of those big monster receivers that's 200 watts per channel, the 40-watt bulb will just turn on even under idle. But remember, this thing only has a 2-amp fuse in it. So it's, you know that its idling current is going to be very low. So all that light bulb does is we're putting the light bulb in series with the line cord. So I have this little socket down here, and the power cord comes into it, goes to one side of the socket. Then we come out of the socket of the other prong, and we go into one side of the light bulb. We come out of the other side of the light bulb and go into the other side of the mains. And that's how it works. I guess I could draw that for you. I would say the majority of you know what this is, but in case you don't, you can go online and look up dim bulb tester, and you'll see all kinds of things. But all you really have is you have your mains cord right here. Okay. I'll zoom in a little bit for you and move this up. And you just have one line going here. And you can see there's the light bulb. And the other part of the mains line is here. And you have your socket. And that's all you have. So essentially, when you plug your device into that, right? When you plug that into there, this light bulb is in series with the device that you're plugging in, and that's going to limit the current. If there's a dead short, the light bulb will light up bright. If there's not a dead short, the bulb will be dim, and that's where the term dim bulb tester comes from. So that's all we have over there. There are many different versions of that, and you know, some people have made some pretty fancy ones, but mine's just a light bulb in a socket. And then I did one extra thing, and a lot of people do, and that is to put a bypass switch on it. And all that is we can take a switch here and if I throw that switch, it just puts a short across here and then allows full power out to the device. So if you look over here, there's the little switch under there. And I also put a fuse in line down here with this as well. And you can change the value of that fuse to whatever you want. So you can put any level of protection you need. It's a really versatile little circuit. It works very well. So let's plug this in and see what it looks like. Okay, hopefully we have everything in shot here. So here's our dim bulb tester. So right there is where we're going to look for the light when we turn this thing on. We should see the panel lamp come on if this works. And we should see some kind of voltage on the voltmeter because I just have it connected across one of the main filter capacitors. So we're going to check just to see if there's power. So here we go. Let's turn it on. And you can see it lights up. We have panel lamp. It's really hard to see on the camera. It's glowing very dimly. You can see that our dim bulb went way down. See how that filament is just glowing? It's not really, really bright. If that was a dead short, that would be lit up white hot light. You know, it would be bright light. Now, one thing I did notice is looking down here, this started out at about 35 volts while we were talking. You can see the voltage is climbing. It's up to 56 volts. And if I recall correctly, on the schematic I have that's not correct for this, I think the amplifier is the same amplifier though. I think it is something like a 70 volt power supply to the outputs. So it kind of doesn't surprise me that we're seeing that level of voltage. And you can see this dim bulb's even getting dimmer yet. It's almost out now. So now that all the capacitors have charged up, this thing's sitting very, very low idle current. So there's a possibility that this amp might, even as hack jobbed as it is, it may work. So let's see if we get any sound. Okay, I now have the amplifier connected to some speakers and I have an antenna, and we are set to tuner now. And I have the volume all the way down. You don't always want to just connect speakers when you're testing something unless you know what you're doing. Some types of amplifiers can have, if you have a shorted output, there's a possibility that you could get DC out to your speakers and it'll damage your speakers. But in this case, this one, the way the amp's designed, there's actually a capacitor between the output section and the speakers. We won't get into the design of the amplifier today, but it's safe to connect the speakers. So I'm going to turn this on now and we're going to see if we get any sound out of the two channels. Okay. So there's no really bad hum. There's a little bit of hum. And of course there's all kinds of static in the volume control. So we definitely have sound on one channel but not the other. And it could be noisy controls, it could be any number of things, but if you notice when I move this, even the least little bit, it's very staticky. And you can see the dim bulb whenever you get that static. I'll show you that. You can see where. But we are not getting any sound at all. So, and it doesn't look like the tuner is doing anything whatsoever. There's no activity here. So, definitely have some problems. So we're going to have our work cut out for us on this, but at least we know it turns on, and we know that at least you're getting some sound out of one channel but not the other. So amplifier's bad, tuner is not working, basically the whole receiver is not working. So now the next thing we could do would be to feed a signal into it and all that, but I'm not even going to go there with it. We're going to have to work on the amplifier. But that's the way you power one of these things up. Now another method to power something up carefully would be with a device like this. This is called a variac, and the reason it's called a variac, it's kind of a word that means variable AC. You can think of it that way. And what this is, it's a transformer. It's like a toroid transformer in there, and it has a movable tap on it. So you can rotate this knob, and it starts at 0 volts, and it actually will go up to about 130 to 140 volts. So it actually can boost the voltage ever so slightly above the 125 volts mains. Now if it's over in Europe or so forth, you're dealing with 240 volts, but same thing, it's just the voltage is different. And essentially what you're doing is you plug the variac into your mains, and then you have this socket where you would plug your device under test into the variac. And then what we can do is, you see there's a voltage meter there, a voltmeter, and this will show you your mains voltage as you dial this up. So I'll unplug this for a moment, we'll turn it on and I'll show you. So as I rotate this, you can see the voltage will climb up. And this meter actually goes up to 300 volts. So you could see 50, 100, and 150 volts. You could see it's reading right around 150 roughly. So we start at 0 volts, and you would plug your device into it. And fancier versions of this will also have an amp meter in it, so you can monitor the current, and that's extremely important. So normally I do not power anything up just like this. I will actually have an amp meter and voltmeter on this as I do it. Now, some of you have seen my setup. I have that red one back there. That's a much larger version of this, but it's the same thing, just handles more current. And it connects up there to an isolation transformer and to the power monitor, which, turn that on, you can see it can read the voltage, the current, the wattage, and the power factor. Okay, but I'm not going to use that today. I'm just going to keep it simple. And if you really want to be careful, you can actually put this variac in conjunction with your dim bulb tester and use a little bit higher wattage bulb, and that will help limit the current a little bit. Or you can use a power cord, with another power socket here, and have the 2 wires separated, and you can put your little amp meter, if you have a little amp clamp or something, to monitor the current. Different things like that. But we're just going to power this up very slowly, and I'm not going to put full power on it. We're only going to run it up to maybe 50 volts, because you'll get the point. I don't like using the variac method on solid state equipment like this for a whole myriad of reasons. One, it sometimes will mess around with the protection circuits in these solid state amps. Other times, sometimes when you're powering up with a variac, there may be a faulty capacitor, and you're not going to really see it until it's too late. You'll get it powered up to a certain point, and then boom, the cap shorts out because it's been sitting so long. And, there's no current limiting, so the thing, damages. And that's why I don't use a variac all the time. But it is a useful tool, and under certain circumstances, it's good. In this instance, I would not use one. I prefer the dim bulb. But we'll bring it up. In order to do that, we turn the power on. And you can see there's 0 volts, so there's nothing here. But you're going to see as I turn this up, so we're going to put 10 volts on it. And you can see already it's starting to charge the capacitors on the power supply. And the idea is you just want to watch this. And a telltale sign, if you're drawing heavy current, is the voltage will climb like this. It'll climb gradually. But you'll get to a point where if something starts to short out or draw heavy current, you'll see this voltage rapidly drop. It'll just suddenly drop. When you see that, when you're using the variac method, there's something that's not right. You turn it off very quickly, and you have to find what your problem is. So you can see as I go up, it seems to be okay. And right now, according to our meter here, we're just approaching 50 volts going in. So 50 volts mains is giving us about 28.9 volts DC on the power supply. And you get the point. And you heard, okay, there was just a little pop, and you can see the light starting to come on. So the amplifier is now starting to turn on a little bit. And so forth. You can power it up, and then the amplifier will somewhat work a little bit. You can see once again it's all staticky. So that's how you use a variac to power something up. So those are the two methods, okay? Again, it depends on how old the device is, and it depends on how well you know it. You notice on this one, this is a really good example why I never trust just plugging something in that I don't know. Now, if this was just something I didn't care about, sure, what do you got to lose, you know? But if it's a piece of audio gear that you are going to, especially if it's somebody else's equipment and you're going to repair it for them, you don't want to take those kinds of chances. If it's just something that you're playing with and you're learning on and you don't care, plug it in, you know? If you blow the fuse on the back or damage some parts, who cares, you know? But in this case, I want to restore this one, so we brought it up carefully. So anyway, I hope that's it. This is the first part of this series, and that's how I power something up for the first time. And that's a little bit of my reasoning why sometimes I choose to take the cover off and look inside before I turn anything on, because just like in this amp, you never know what kind of surprises lurk inside there until you look. So that's it for this one. On the next video, we're going to get a little deeper into the design of this amp, and we're going to start looking at how we go about repairing something that has so much problems with it. So that is it for this video. It's all I have time for, unfortunately, because I've been so busy. I don't know when the next time I'll get on the bench. The weekend is here coming up, so I may get another little chance to go here this weekend. Until then, though, I wish you all peace, joy, happiness, and good health in your lives. Hope everything's going well with all of you. And we'll see you again really soon, where we'll continue this. Take care. Bye-bye.